Welcome to another episode of Tech Talk, where we dive into the fascinating world of computer science and engineering. I'm your host, and today we're exploring the incredible applications of vectors, quaternions, and matrices. These mathematical concepts aren't just theoretical, they play a critical role in various fields, from computer graphics to robotics. So, let's jump right in. Now, you might be wondering, what exactly are vectors, quaternions, and matrices? Well, let's break it down a bit. Vectors are essentially quantities that have both a magnitude and a direction. Think of them as arrows pointing in space, very handy in computer graphics for representing positions, velocities, and forces. Matrices, on the other hand, are rectangular arrays of numbers that can perform transformations. They're like tools that can help us rotate, scale, or translate these vectors around in our 3D spaces. And then we have quaternions. They might sound a bit complex, but they're actually quite fascinating. They're a number system that extends complex numbers and are particularly useful for rotating objects in three-dimensional space without running into the hiccups of gimbal lock, which, if you've ever worked on 3D graphics, you know can be a real pain. Quaternions keep things smooth, which is crucial for animations and simulations in video games and movies. So, let's bring this to life with a few examples. Imagine you're playing a video game. The characters you control need to navigate a 3D world. The way they move, how they turn, pivot, or even fly through the air depends heavily on these mathematical tools. For instance, when a character turns, it uses quaternions to rotate smoothly, ensuring the animation looks realistic and fluid. Pretty cool, right? And speaking of real-world applications, these concepts also have vital uses in robotics. If you think about drones or autonomous vehicles, they rely on quaternion calculations to adjust their direction and orientation in space dynamically. It's like giving them the ability to dance through the air while knowing exactly where they're headed. Now, if we lighten things up a bit, let's discuss biochemistry. Yes, you heard that right. Vectors and matrices are not just for tech and gaming. They are also used in structural chemistry and cosmology modeling. For example, when scientists want to understand the molecular structure of a compound, they rely on the geometric transformations provided by these mathematical constructs. It's the same principles that govern our universe, and we can see the beauty in mathematics applied to nature. As we're discussing these complex topics, I'd love to hear your thoughts. Have you ever thought about how mathematics and technology intersect in your daily life? Maybe when using GPS navigations or even booking a flight? It's everywhere. Before we wrap up, let's touch on compatibility. If you're developing software for embedded systems, you might want to consider using a feature set that allows for no-STID compatibilities. This lets developers work in environments without the larger standard library. It's efficient and perfect for resource-constrained devices, like those that help steer drones or assist with environmental monitoring. So as we end today's episode, just to recap, vectors help us understand direction and movement, matrices allow us to perform transformations, and quaternions provide a smooth way to rotate in 3D space. From computer graphics to robotics and beyond, the applications of these mathematical tools are vast and profound. Thank you for joining me today on Tech Talk. I hope you now have a deeper appreciation for the math behind the magic. Until next time, keep exploring, keep questioning, and remember, the world is full of fascinating connections just waiting to be discovered.